fun.
Good job on the table.
Yeah, pretty much having a little box there, isn't it?
Cool. Good morning. We're GDP Group 4, and today we'll be presenting our project report on electric frames, just load balancing in figure energy using social networks. So I'm Thomas Rees-Mundell, this is Craig Saunders, and Tom Milligan. Just give you a quick overview, about 20 minutes, just quick background of the project, and then figure energy background, followed by just a discussion of approach we took for the project, short demonstration, our teamwork, and then conclusions and then questions in the last 5 minutes. So, project background. For this project, we faced the problem of creating smart energy users. So the point of this project was to help create smart energy users out of users of smart energy users out of just normal home users. So how do you create these smart energy users? Well, a smart energy user is someone who can understand the context of their energy usage in terms of how much impact it has in terms of their energy usage and their spend, as well as their carbon footprint. Helping them understand how they can reduce this carbon footprint throughout the day. So this is a problem due to the electricity grid currently experiencing peaks and troughs. The peaks and troughs tend to be at certain points of the day when everyone tends to use the electricity grid, and this can cause an unstable load throughout the day. Ideally, they prefer to have a flatter load throughout the day so that it can be predictable load, and the energy companies will have to turn on these things called peaker plants, which are essentially reserves energy supplies which are less efficient than the energy supply for the main load. This would then hopefully, in theory, produce a predictable flat load through the smart users to reduce the users' energy bills, maybe by providing incentives for the users by reducing their energy bill per month depending on how predictable their load was for the previous month. This could be done, as way we've looked at it, is by creation of teams, so team collaboration of energy usage through the use of social networking, and we'll just show you that in a bit. So what is Figure Energy? Figure Energy is an existing ECS project aimed to help users essentially create smart users through understanding electrical energy consumption. This is currently deployed in a web-based application, viewable through the browser, using the Django web framework through Python and a persistent MySQL database to store the energy data brought back from AlertMe, which I'll show you in a sec. Some of the features of Figure Energy, a graphical view of energy consumption, the annotation of these energy events to provide qualitative information to certain energy events throughout the day, some energy statistics about your energy usage for the current usage as well as your future predicted usage, and what if energy consumption simulator. So some of the screenshots of Figure Energy, you might have seen before. These are just tagging different energy events, so these are obviously 2 showers throughout the day. This is the bathtub interface, which allows you to simulate different energy usage depending on which events you put in the practice tub. You can see how much energy it displaces and how much the energy usage goes up by putting these different events in the bathtub. And this is the live view, so the information that's coming in currently from the AlertMe account and predictions for the week ahead. There's also a savings and rewards panel, which is something that yet to be implemented, but is being looked at through Figure Energy to provide those savings and rewards incentives to help people decide to use less energy. So just a quick architectural overview of Figure Energy, what we've built upon. So the AlertMe meter currently pushes this information to the AlertMe servers, which then pulled into Figure Energy through the ECS firewall on the cron job, which runs at a regular interval. This then updates the MySQL database, which is persistent and stores all the data related to each of the AlertMe accounts and the energy data from the AlertMe meter. So a request comes in from the web application through Nginx, which, if it's a static page, returns the page to the user. If it's a dynamic request, it goes to Apache, which communicates with Django and then decides what to do with the web page request using the MySQL database data as the backend. So I'll hand over to Craig for the project brief.